Weather by Kate O'Donnell. Weather is a temporary condition of the atmosphere in a specific area. Climate is the average weather of an area over a long period of time. The atmosphere is all of the gases that surround Earth. It is made up of layers with different properties. The troposphere is the layer closest to the surface of the Earth. Almost all weather happens in the troposphere, but occasionally weather can stretch into the stratosphere, the layer above the troposphere. Weather is made up of 6 parts: temperature, atmospheric pressure, wind, humidity, precipitation, and cloudiness. These parts combine to describe the weather in a location. Temperature is a measure of how hot or cold an area is. We measure temperature using a thermometer. Gabriel Fahrenheit invented the first mercury thermometer. Mercury inside a tube expands and contracts as the temperature around it changes. In the United States, we use the Fahrenheit scale to name temperatures. In the Fahrenheit scale, water freezes at 32 degrees and boils at 212 degrees. The rest of the world uses the Celsius scale to name temperatures. In the Celsius scale, water freezes at 0 degrees and boils at 100 degrees. In the troposphere, the air gets colder as elevation increases, so the top of a mountain is colder than the valley below it. Sunlight hits the equator more directly at the poles, so the air at the equator is warmer than the air at the poles. Atmospheric pressure is the weight of the atmosphere above us. Meteorologists measure atmospheric pressure in atmospheres, millibars, and inches of mercury. 1 atmosphere is equal to 1,013.25 millibars, or 29.9 inches of mercury. A barometer is a tool used to measure atmospheric pressure. Atmospheric pressure is higher at lower elevations because more of the atmosphere is above the surface. At sea level, the atmospheric pressure is equal to 1 atmosphere. At the top of Mount Kilimanjaro in Tanzania, the atmospheric pressure is 0.4 atmospheres. Atmospheric pressure also changes depending on the temperature of the air. Warm air rises, so atmospheric pressure in warm areas is low because there are fewer air molecules near the surface of the Earth. Low pressure areas are usually warmer with storms and rain. Cold air falls, so atmospheric pressure in cold areas is high because there are more air molecules near the surface of the Earth. High pressure areas are usually cooler with clear skies. Wind is the movement of air. Air moves due to differences in pressure and temperature. Air molecules move from colder high-pressure areas to warmer low-pressure areas. When warm air rises, fewer air molecules are left near the surface of the Earth. Colder air molecules rush in to fill the space left behind by the rising warm air molecules. The higher the pressure difference between 2 areas, the faster the wind blows. There are both local and global winds. Local winds are caused by the geography of the area, including bodies of water and mountains. The winds move from areas of high pressure to low pressure in a straight line. Global winds are much larger than local winds. They are caused by the uneven heating of the Earth and the Earth's rotation. As warm air heated by the sun at the equator rises, cold air from the poles rush to fill its place. These winds do not move in a straight line. They curve based on the spin of the Earth. The equator spins faster than the poles, so as air from the North Pole moves south, it deflects to the left. As air from the South Pole moves north, it deflects to the right. The way the speed of the Earth's rotation changes the direction of the moving wind and water is called the Coriolis effect. Humidity is the measure of how much water vapor is in the air. Meteorologists usually report humidity as relative humidity. Relative humidity is the percentage of the maximum amount of water vapor air can hold at a given temperature. If the relative humidity is 100%, the air is saturated and can't hold any more water vapor. The extra water vapor condenses into liquid water and forms fog. Warm air can hold more water vapor than cold air. As warm air rises, it cools, and the amount of water vapor it can hold drops, and clouds made up of liquid water form. Air temperature also decreases at night, and the amount of water vapor in the air can hold decreases. This is why you may find dew on your lawn in the morning. Precipitation is water that falls from the sky. Depending on air temperature, the precipitation can be rain, hail, or snow. At high altitudes where the air is colder, the water vapor from the atmosphere condenses into liquid water and forms clouds. When the droplets of water get too heavy, they fall as precipitation. Most precipitation starts as snow at high altitudes, but becomes rain closer to the Earth's surface. Most precipitation happens in low-pressure areas where warm air rises, because rising warm air leads to clouds. High-pressure areas have little precipitation because the falling air doesn't form clouds. The world's largest deserts, including the Sahara Desert and Antarctica, are both in high-pressure areas. Cloudiness is the number of clouds in the sky in a given area. Meteorologists measure cloudiness in octas, or eighths, of the sky. A measurement of 0 octas means there are no clouds in the sky, and a measurement of 8 octas means the sky is full of clouds. Meteorologists classify clouds based on how they look. Stratus clouds are flat and may have layers. Cumulus clouds are puffy. Cirrus clouds are wispy. Nimbus clouds are full of rain. Their heights above the ground also classify clouds. High-level clouds form above 20,000 feet, middle-level clouds form between 6,500 and 20,000 feet, and low-level clouds form below 6,500 feet. Clouds are an important part of weather because they lead to precipitation, such as rain or snow. Clouds also affect air temperature. During the day, they block heat from the sun, making the temperature colder. At night, clouds trap heat from the surface of the Earth so it can't escape to space. This makes cloudy nights warmer than clear nights. Meteorologists have a variety of tools to monitor the weather. They use thermometers to measure air temperature and barometers to measure air pressure. Since the 1930s, meteorologists have been sending weather balloons up into the atmosphere to gather information about the weather. Weather balloons are still the most accurate sources of information about the weather. In 1960, NASA sent the first weather satellite into space. For the first time, meteorologists could watch the weather from space. There are 2 types of weather satellites in space. Geostationary satellites stay above the same part of the Earth all the time. Orbiting satellites circle the Earth every 12 hours. Watching current weather helps meteorologists make predictions about future weather. These predictions help people prepare for how coming weather will affect their lives. The end.